Let's look at case 3, and that is where we have non-repeating irreducible quadratics. So our quadratic, we know, is of the form ax squared plus bx plus c. If the discriminant b squared minus 4ac is less than 0, then it is an irreducible quadratic. Okay? So it's best to illustrate with an example here. So let's actually do the whole thing where we decompose it and integrate it. So perhaps we are looking at the case where we have 2x plus 1 over x minus 1 and then x squared plus 4. That is a linear factor. We know what to do with this. When we have a irreducible quadratic, we will instead of having a constant, so notice when we have a linear factor, we have 1 degree less on the top, and we want to have 1 degree less of our irreducible quadratic, so we want actually a linear factor above. So that is bx plus c. Okay, so we have an irreducible quadratic on the bottom, then the top will be a 1 degree less, which is going to be a linear factor. When we had a linear factor in the denominator, then we go a degree lower, and we have just a single constant on the top. Right? We're decomposing them into proper rational functions. Oops, I lost my dx also. So there's our dx, so we're going to do that, dx. Okay, I will come back to the integral. I'm just going to work on the decomposition here. So I'm going to come back here and write it again, x minus 1, x squared plus 4 equals what we just said, and we will proceed as we have done in the previous examples. We will multiply everything through by the least common denominator, which is this, and all the factors that aren't present will cancel out. So we will be left with 2x plus 1 on the left, because the denominator should cancel by design, equals a times the x minus 1 cancels, so x squared plus 4, plus the bx plus c times this entire factor here, x minus 1. Okay, so we have 3 unknowns, and we would like to, so that means we have to have 3 different equations to find those unknowns. We like the zeroing out, but notice we cannot zero that one out, right, because of that irreducible quadraticness. So we will not choose that case, but we can zero out that one. So let's start with x being 1, just to make it easier. And then we get 2 plus 1 equals a times 5 plus b plus c, right, times, 0. I shouldn't have even written that. That one's all 0 because of that zeroing out. So what we got here was a is equal to 3/5. That's cool. All right, so we have to think of a different x value. Let's try 0. 0 is always nice, or often nice. So if we plug that in onto the left, we get 1. And on the right, we get 4a. And then on the left, we get plus, so that piece zeroes out. So c times -1. So we have 1 equals 4a minus c. Now we can actually figure out c because we know that a is 3/5, right? So 1 is equal to 4 times 3/5 minus c. Or 5/5 minus 12/5 equals minus c. So this tells me c is positive 7/5. Love it. Okay, so now we know a and we know c. So let's pick another x value so that we can solve for b. Let's do -1. So if x is equal to -1, we get, let's see, what do we get on the left? -2 plus 1, so -1 is equal to still 5a plus b times -1 plus c times -2. It's kind of gross, but let's plug in everything we know. So -1 equals a is 3/5, so this becomes just, 3. Plus, now we have, I'm going to distribute that -2, so it's really 2b. I don't need this parenthesis anymore. And distribute that -2c, so really -14/5. So if I move everything over, I have 2, sorry, that's not true, -4 plus 14/5 equals 2b. And so 4/5 is really what? -20/5. So let's just fix that. -20/5. So this is really -6/5. Then divided by 2. So divided by 1/2 is b. This tells me that b, well, let me just write equals. b is equal to -3/5. Algebra. Okay, so now let's go back to the integral that we were trying to solve originally. So let me try to write it down here. It became this expression, right? So let's see if I can make it nicer. We have the integral of a, which is 3/5 over x minus 1. I'm going to split the bx plus c apart. So what is b? B is -3/5. So I'm going to say minus 3/5 x over x squared plus 4. And then lastly, the c, which is 7/5. So plus 7/5 over x squared plus 4 all dx. Okay, hopefully you see that this is just a natural log and this one is just an arctan, right? We have to be careful though with that arctan, because that's not x squared plus 1, it's x squared plus 4. All right, so this one should just come out to 3/5 natural log of this. I can pull the 7/5 out here, but I still have to deal with 1 over x squared plus 4. And this one is actually just a u sub. So let's come down here. I'm going to get rid of this for a minute. And let's do our u sub on that first one. So if I have 3/5 times the integral of x over x squared plus 4 dx, I come over here and say u is this, du is this. I put in a 2, I take out a 1/2. So then this really is, what is that, 3/10 integral of 1 over u du, which is 3/10 natural log of the absolute value of u, which is, in our case, 3/10 natural log of, I don't need absolute value bars if it's, that's what that piece is. So this should be minus 3/10 ln of x squared plus 4. Plus, I'm going to go ahead and put 7/5 there. But we got to deal with this, okay? So let's come over here and remember some things. If I want to find, we should remember that this is arctangent, okay? Now, if I change that one to something else, I have to be careful. So, for example, if I have 1 over x squared, let's say, plus a squared, I am going to factor that a squared out, right? So this really is 1 over, I'm going to say, if I pulled out an a squared here, this becomes x squared over a squared, right, plus 1. Huh? I'm going to pull one of those a's out. And I'm going to rewrite this as x over a squared plus 1. And then I'm going to leave one of those over here because I know what's coming. Okay, just split the 1 over a squared up. So now I'm going to do a little u sub on that guy. So u is equal to x over a, which means du is 1 over a dx. Just right there. Okay, so then this integral becomes 1 over a, 1 over u squared plus 1 du, which that I know to be arc tangent of u. But my u is actually x over a. So this is 1 over a arc tangent of x over a. So in our problem, we were so close. Our a here is 2, right? We have 4, which is 2 squared. So this should be, I wish I could make it, I'll make it come down below. This should be plus 7/5 times 1/2 arctangent of x over 2. Let's see.